Hi everyone, welcome back to part 2 of our DEX smart contracts. In the part 1, let me give you a quick overview what we have done. We initialized the Foundry project. We created a new file rsdex.sol. We installed OpenJeplin libraries, and we in the previous part we returned all the internal function what we need in this smart contract. We even declare our structure, some state variables, and we added this add liquidity functions. And you can see here the logic. We declared the mint internal mint function, and we declared also burn function, and we have update function. And in this video we are going to build uh, we are going to complete entire smart contract. We going to declare the external and public function what we need, and we as I said, we are going to add the functionality advanced functionalities like pool creation, add liquidity and swapping, and so on. So let's get started and start building our smart contract. So here we are already commented this out here, public and external function right below this. Let's start writing function. Let's start with pool creation. So let's declare create pool function, create pool, which takes two parameter. To create pool you require two token addresses. So let's address of the, let's say, token A, and the address of the token B, and uh, let's make it external, and it will return the pool id. And as I said, the pool id should be in bytes format. So copilot suggesting us right. And now let's go inside the function body, and we are following here the industry best practices, which is CEI, check effect interactions. So let's add the condition here. Require, the first condition is token A. Let's copy it from here. Token A should not equal to uh, should not equal to let's say should not equal to token B, otherwise it will throw an error, identical tokens. That's it. File it suggesting us right. And let's add another condition here. Token A should not to address 0, otherwise, and token B should not equal to address 0, or it will throw, or it will revert an error of 0 address. Now let's sort tokens to ensure consistent pool id. For that, let's add address of the token 0, declare the variable here, and address of the token token 1 is equal to token A less than token B. And now let's add a condition if, oh, not like this. Let's add a condition token A and token B, and token B and token A, like this and then like this. Let's format the document, and there we go. Now let's add pool id is equal to, here we are going to use the inbuilt function kcook256, which takes an argument of abi dot, and we are going to use encode pact, and inside that we are going to fact token 0 and token 1. That's it. Now let's add another condition here. Require, if you remember, we in the previous video we declared the mapping here. There we go, pool exist. So let's copy this from here. If pool not exist, where we are, add liquidity, yeah, there. If pool not exist of the pool id, then it will throw an error or the revert an error, pull already exist. There we go. And now let's add uh, let's declare the variable here, pull storage. Let's name it pull, and let's say is equal to uh, pulls, and inside that let's add a pull id. uh, we have the structure here, and use this variable pull dot token a is equal to IRC20 token 0, pull dot token b and IRC token 1. And if pull exists, and inside that let's pass pull id and let's make it true. And since we are returning bytes 32 of the pull id, let's return this, and we're done with this function. So I hope you understand what we are doing here. We just build a create pull function. Now let's create another function for the liquidity. So user should add liquidity in our protocol or in our smart contract. For that, let's create a function add liquidity, and for adding liquidity, it will take 6 parameters. But before that taking parameters, let's make it external and non-reentrant. Also, it will returns uint 256 amount a, uint 256 amount b, and uint 256 liquidity. And there we go. Let's add the function's body, and it will take 6 parameters, bytes 32 of the pull id, and let's add uint 256 amount a desired, amount b desired, amount a mean, amount b mean, and the address of the 2. I forget to add the address of the 2. That's address of the 2, and there we go. Now let's go ahead and let's write the function's body. So we functions add liquidity, inside that we take 6 parameters. We are from user we are taking pull id, amount a desired, whatever the amount he want to add liquidity, he or she want to add liquidity, amount a mean and amount b mean, and the address. So let's go ahead and start writing the logic of our function. It will be very simple logic we are going to add here. So first let's follow the CAI require. If let's first check pull exist. Let's go ahead, pull exist, and inside that pass the pull id, and if it is not exist, syntax error, and let's revert an error, pull does not exist. There we go. Yeah, this is the syntax error, and there we go. And now let's declare here another state local variable, pull of the storage. Let's name it pull is equal to pulls, and inside that let's pass pull id. And now let's go ahead and amount a and amount b. Let me go here, amount b is equal to, let's call here our add liquidity function. And if you see here add liquidity, which is taking 5 parameters, and we have to pass these 5 parameters here. Let's first add pool, amount A desired, amount B desired, amount A mean, and amount B mean. We are calling this function here, and there we go. Let's go ahead, and now let's add pool dot token A, and we are going to use here the inbuilt function say transfer from token A dot say transfer from, and it takes 3 parameters. First is message dot sender, address of this, and amount A. Same here, pool dot token B, transfer from message dot sender, address this, and amount B. Now let's initialize liquidity here. Liquidity is equal to, and we are going to call the mint function here. Our code editor also suggesting us, and which takes 4 parameters, sorry, 2 parameters, I guess. Mint function, yeah, you can see it is taking 2 parameters, pool and address of the 2. So let's go, and it already taken pool and 2 we already given, and let's emit an event here, which we have to declare. Emit events are very important when liquid. Let's first declare, and I will liquidity added, and inside that let's pass to amount A, amount B, and liquidity. Events, why events are important? When you are indexing data from the for the front end or any other using protocols like the graph, it is very important to track data, index, and query data. So let's go here, and we already structured the everything. So let's add, let's declare event here, event liquidity added. Inside that we have to pass, let's index the address indexed, and let's say provider. We need to also pass the token A amount, token A amount. We also need to pass, what is this wrong here, expected is got identifier. This is just VS Code error, probably event 256 of the token B amount and the liquidity. There we go, and let's format indexed. That's it. This was there, and there we go. We declare the event here. Now let's go ahead, and let's create another function. So far we did pool creation and add liquidity. Now we just like we add liquidity, add liquidity, we need to also have a remove liquidity function. So this is very simple. Let's go ahead, and let's declare this function remove liquidity. Yeah, oh, it is not like this. The copilot suggesting us something wrong. So let's say remove liquidity, and let's first make it external non-reentrant, and it will return the event amount A and amount B. And now let's take one by one the parameters. Bytes 32 of the pool ID, and also it will take how much liquidity they have to remove. So let's add the liquidity, we also amount a min and amount b min, u int 56 amount a min, amount b min, and the address of the two. So let's format this so our code look beautiful. And now let's follow our same pattern. So let's first check if pool exists or not. So copy this from here and paste here, and now go ahead and the same pools storage pool id, there we go. Let's format again, and now let's go ahead and let's declare here amount a, and amount b is equal to, let's call the burn function here that we declared in the previous part. I hope you you have you remember this. So it takes three parameters, if you can see here, the pool, liquidity, and address of the two. So let's go back, and here inside the burn we have to pass pool, liquidity, and the two address two. And now let's check here the add the condition of require amount a is greater than or is equal to amount a min, otherwise it will throw an error insufficient a amount. And let's add another condition here, require amount b is greater than amount b min, greater than or is equal to amount b min or insufficient amount. And now let's emit an event here, liquidity removed, and two amount a, amount b, and liquidity. Now let's go back here, let's first copy liquidity removed. Let's go back here, events, and let's declare the event here, liquidity removed, and inside that we have to pass address of the provider, token a amount, token b amount, and liquidity. Thanks to Copilot for suggesting. There we go. Let's format. Now we created create pool function, we add liquidity function, also remove liquidity. Now let's go ahead and let's declare our most important function, which is for swapping. It will be huge function, so focus here, and bear with me if it will not make sense initially. To let's follow along with me, and I am going to give entire source code if you stuck anywhere. So this will be very important function here, just follow along with me. So let's go here, let's declare this function swap, and let's first make it external and non-reentrant, and it will return the amount, whatever the amount uh, going out. So let's make it returns what it will return, amount out, you input 56 amount out. Let's go and let's take a parameters here. So first it will take bytes of the pool id, and whatever the amount uh, token in, or the let's address token in, and let's go ahead, amount in, address not u in t256, let's amount in, and amount out min u int 256 amount out min and the address of the address of the 2. That's it. Let's format this, and you can see here we declare the swap function. We are taking this 5 parameters. We made it external, non-reentrant, and we are ready to write our functions logic. So let's first copy this from here. Let's first check this. Let's declare this from here, and now let's add another require condition here. Require the condition is token in should be is equal to address of the pool dot token A, or where is the or token in is equal to address pool dot token B, otherwise it will throw an error, invalid token. Thanks to Copilot for suggesting me the right error. And now let's go ahead, let's declare another variable here. Bool is token A is equal to token in, and let's say is equal to address of the pool dot token A. And let's go ahead, and now let's declare uint 256 reserve in uint 256 reserve out is equal to token A. Now we need to check here if pool dot reserve A, it is also suggesting us other pool dot reserve B, otherwise pool dot reserve B, pool dot reserve A. And there we go. Let's format this. There we go. That's it. Now go ahead, and let's keep writing our logic. Amount out is equal to get amount out. Let's call our another function we have to write, but we will write its logic later. First let's declare this. Let's keep writing this function first. Amount out, and inside that we have to pass amount in reserve in. Let's declare the reserve in and reserve out, not the is token A. That's it. Let's go, and that's it. Now let's add the condition here, not the if else condition. Require, and inside that require amount out should be greater than or is equal to amount out min, otherwise insufficient output amount. Now let's initialize, not this one. Let's go ahead and let's initialize IERC Let's copy this from here. The first one, IERC, where we go, IERC20, and inside that let's pass token in dot safe transfer from, and inside that let's pass message dot sender address of this and amount in. There we go. And now let's add the condition here. If else condition, if each token A, if each token A let's go and write body, and inside that body let's keep writing logic pull dot token A, pull dot token A, it is suggesting us right, let's make it plus equal to amount in, and pull dot reserve B plus equal to amount out, and pull dot, I think it is not token A, it is the reserve A. We are adding the, yeah, sometimes mistakes, pull dot token B dot, let's copy this function from here, dot shape transfer from, and inside that we have to pass to and amount out. Let's copy the amount out, and that's it. And this is not enough, we need to write more else, and inside that else, not the pull, inside that else we need to pass pull dot reserve B, reserve B plus equal to amount in, and pull dot reserve A plus equal to amount out, and pull dot token A dot transfer from to and amount out, and that's it. And we also need to create, if you remember in the previous part we created the update function which takes two parameters. If you go here and you can see it will take, it is taking pull and pull id. So let's call this function here, where we go add liquidity. So inside that update function we are passing pull and pull id, and we have to emit an event here which is the swap, and inside that swap event we need to pass message dot sender token in, not is token A, token in, and we need to create a custom logic here. Let's go here and let's create each token A, if is token A, let's pass the address of the pull dot token B, and else address of the pull dot token A. That's it. And now let's go ahead and create amount in and amount out, and we also need to declare this event on top. So let's go on top, and this is our last event. Let's go, where are the events? Yeah, event swap, and inside that let's pass one by one address indexed sender, or the, let's say, user, and address of the, let's index this one, token in, address token out, amount in and amount out, int 256 amount in and amount out. There we go. Let's format the document. It is not formatting because, let's format now. Yeah, it's formatted, and we're done with events. And now let's keep writing more functions. We created the most important swap function. Now if you remember, we need to create this function, so this error will go away. So let's go ahead and write this function get amount out. Let's first make it public, and let's make it pure, and it will return whatever the amount is going out. And I forget the spelling, public pure returns. And if you see, we are passing, what is the error, to but given expected full dot token, two arguments given but expected 3, get amount out. It is taking 3 arguments. Let's first declare, we will solve entire errors, so don't worry. You int 256, which is the amount in, the another reserve in, and another the reserve out. That's it. And let's add the logic. If you, what is the, these errors are coming from, let me see. To and amount out, pull dot token b, to and amount out, pull dot token b, pull dot token a. Don't worry, this will be VS code errors, token b, and it will be fine. I will make it, and I will show you also how you can solve these errors. So let's keep writing the logic of our function. Amount out, let's go inside this function's body, and let's add the condition here. Require, the first condition is to amount in should be greater than 0, otherwise it will we throw revert an error. So let's amount in should be greater than 0, or it will be throw revert an error insufficient input amount. Let's add another condition here. Require reserve in, and inside that, let's, it should be less than 0, and sorry, greater than 0, and reserve out is greater than 0, so it will throw an error in invalid liquid, insufficient liquidity. Now let's declare the variables here, local variables. I want 256 amount in with fee, amount in with fee, and is equal to amount in. Let's multiply this with our p denominator, and let's minus p numerator that we declared in the previous part. And let's go ahead, you int 256 numerator is equal to amount in with fee. Let's copy this here from here, and let's multiply this for the reserve out. Thanks to Copilot, let's declare another int 256, and int 256 denominator equal to reserve in, and let's multiply this to the denominator, and we need to make it plus amount in with fee. And let's go ahead and we have to make it amount out is equal to let's copy this at variable from here, and numerator multiply denominator, and let's format this. What we have still 5 errors here, the wrong arguments, there we go. Dot transfer from call two arguments but given expected 2. We need to pass this out. There is something wrong in our logic, but let's go ahead and let's solve this one. I think we'll solve this soon. Maybe this is VS Code error, and due to we will solve this very soon. Let's go ahead and create our next function for the reserve. Get amount out for the get full reserve, get amount in, and the get amount out. We already build this function get amount out. For now we have to make get amount in function. So let's go ahead and let's add this function. We need to create more 2-3 more functions, which is very small functions, but let's go ahead and create another function here for amount in. Let's declare this function get amount out, not out, amount in, get amount in, get amount in. What's wrong with me? So this is going very long and long tutorials, that's why sometimes it how happens. So let's take a parameter, get amount out, reserve in, and amount reserve out, and let's make it public pure, and it will be it will returns the amount in. Let's go, let's write the function's body here. Before writing, let's mount a function get amount, and we forgot to add here the u into 56. Let's copy the u into 56 and u into 56. There we go. Now let's add the condition here. First condition is to require if amount out, let's copy this variable from here, amount out to 0, otherwise we will revert an error, insufficient amount out. And let's add another condition here, the require, what we require, the reserve in should be greater than 0 and reserve out should be greater than 0, otherwise we will revert an error insufficient liquidity. So let's go ahead and let's declare the variable into 56 numerator. Copy this from here, you into 56 numerator, and let's say reserve in multiply amount out, and we also need to multiply this for fee denominator, and let's declare another here even 256 deno. Let's copy this from here, denominator is equal to, let's say, reserve out minus amount out, and let's multiply this by fee numerator, and now amount in is equal to, inside the numerator, copy this from here, and let's divide this for denominator. And that's it. Let's make it the +1 here, and there we go, we are good to go. And now let's keep writing our smart contract, sorry, more functions. Now we are almost done with our smart contract, sorry, almost done with our all the functionalities of our smart contract. So let's go ahead, and we have little 2-3 functions here. Let's create this one. So first function is to function get reserves, or the get reserve, reserve, get reserve, and it will take the pull id in the byte 32 format, pull id, and let's make its visibility external view, and it will return reserve A amount and reserve B, whatever the we have. So let's declare the pull storage pull id, and it will return not reserve, it will return pull dot reserve A and pull dot reserve B. That's it only, and there we go, we done with reserve function. Now let's go ahead and get user liquidity. Let's declare the get user liquidity function. So function get user liquidity, and inside that we have to pass, first take some parameters. First parameter we will take the liquidity, sorry, pull id, and the address of the user, let's make it let's make it external view, and it will returns you int 256, or no need to declare the liquidity here. And inside that let's pass the functions body, and inside that functions body let's add the mapping here. Inside the pull id balance, pull id dot not balances, actually it will add the liquidity and the liquidity of the user. Let's format the documents, and let's go ahead, and we have our very last but not least function. Let's declare get pull id function, get pull id. And how to get pull id? For that, let's add let's take a parameter from user, address of the token a, and address of the token b, And also let's make it external pure return bytes 32, and let's make it not here address token 0. Let's declare here token 0 and address token 1, and is equal to token A should be less than token B. And now let's add here token A and token B. If token A token B, else token B token A. That's it. Let's format the documents, and now it will return. I hope you understanding this tutorial. This is not beginner friendly of course, but these are very simple functionalities, simple logics, not a very much complex. Yeah, there is a complex logic some here, but if you since we know this is just a very basic functionalities we are adding. So let's add the kicker 256, and inside that it is taking two parameters, abi.encode pact, and inside that the argument we have to pass the token 0. This is the token 0 and the token 1. There we go. And we almost done with this smart contract of our DEX smart tutorial. We have two errors here. If token A, let me give you unused local variables 130, there is no here unused parameter 128, there is nothing. Function mutability can be 128, there is no 128 line. This is just VS Code errors. And if you go here, let's run this forge build, and it will wrong argument counter function call shape transfer from what are the wrong shape transfer from. I think inside the swap function we have not shape transfer from, we have to pass shape transfer and shape transfer, and it will go away. Happens sometimes, happens, these are the errors. Now let's compile the smart contract and let's see the error, and there we go. Congratulations, you did it, and we successfully done with our smart contract. This is the complex logic we implemented, and so far we initialize the Foundry project, we installed OpenZeppelin libraries, we have constructor here, we have this event here, liquidity removed, swap, we structured our pool here, we declared state variables. Inside that we have mapping, PD monitor, numerator, minimum liquidity, and we have price oracles here. We have function create pool, we also have function add liquidity, we have function remove liquidity, and we added some of the best logic. We have swap function, which is very important function for us, and we have get amount out, get amount in, we have another function get reserves, we have function get user liquidity, and we have some internal functions add liquidity, mint, we have burn function, so we have update function, and so on. So that's all. We done with our smart contract, and in the upcoming parts we will test and we will deploy it on rootstock networks. So just follow the this DeFi series, follow this DeFi tutorial, the next tutorial, and I will see you in next part. Bye bye.